are moving on to the last part of 3.7 in solving absolute value equations. Except today we're not doing equations, we are solving inequalities. What I need you to remember with inequalities is when you MD and F, when you flip it. Remember you MD and F when you divide or multiply by a negative. So here's the steps. You've been doing the steps for like 3 days now. You've been solving absolute value equations. It's the same thing, except you have to graph your answers and there's an inequality sign. So you definitely want to make sure before you do anything, the absolute value grouping symbol is alone. That is all by itself. And then you create your cases. That's what we've always been doing. Except now when we make our negative case, we have to flip. You have to flip the inequality for that second negative case. Then you solve and graph.
If needed.
If needed. Today you're going to have to graph. Because sometimes things get weird when you graph. Because it's always when you make your cases, remember we always say X is this or this. It's different. Sometimes even though it says the word or, it turns into an and graph. So it gets a little tricky there. Okay? All right. So here's the first example. We're going to solve and graph this. Darn it. The absolute value of 2x is bigger than or equal to 12. Is my absolute value symbol alone?
No.
Yes, it is. It doesn't matter what's inside it, it's what's outside it. It is alone on the outside. It's all by itself. So now I can create my cases. You have 2x is bigger than or equal to 12, or now I'm making that negative case, so I have to flip the inequality symbol. 2x is less than or equal to negative 12. Notice I flipped. So then you have x is bigger than or equal to 6, or x is less than or equal to negative 6. And this is actually an OR. This is still an OR graph. But you'll see it eventually it kind of smushes into an AND graph. So I have a colored in circle at 6 going to the right. A colored in circle at negative 6 going to the left. So same strategy, except you just have to flip. Make sure it's alone, flip it if you need to. Okay, the next one. The absolute value of x minus 3 is less than 6. Is my absolute value symbol alone on the side of the inequality? Meaning, is there anything on the outside of it? Nope. So I can make my cases. X minus 3 is less than 6, or now I'm going to flip because I'm making it negative. X minus 3 is bigger than negative 6. Now I solve both cases. X is less than 9, or x is bigger than negative 3. Now if you don't know where I'm getting these numbers from, show your little algebra steps. Show that you went plus 3 to both sides. That's where I'm getting these numbers from. Okay? So, this is one where it's going to turn into, even though it has an OR, watch what's going to happen. I'm going to make my circle, so x is smaller than 9, so an open circle at 9 going to the left, or x is bigger than negative 3. So I have a circle at negative 3, and I'm going bigger. What's going to happen between these two? They're going to smash together. This is actually an AND graph. Because if you're going this way and this one's going this way, they're going to collide. So it turned into an AND graph. So be careful. I always graph it as normal, and then I look to see, hey, are they going to smash into each other? And then if they do, I just connect them. All right. So again, let me just summarize. The biggest thing, the biggest difference today is you're going to have to flip. That's today. You're going to have to flip your negative case. And then the other big difference today is sometimes an OR graph is really an AND graph when you graph it with absolute value. When you create cases, sometimes it makes an OR turn to an AND. All right, and then just to summarize that we need to get it alone sometimes. So look at, I'm yelling at us here. I'm saying before you make your cases, you have to make sure the absolute value sign is alone. Explanation. That's me yelling at you. Make sure it is alone. And you have no choice. You have to do it, even if you don't love it. So the absolute value of 2x minus 1 minus 3 is less than 4. Is my absolute value sign by itself? No, it's not, because this minus 3 is by it. So I need to get rid of that minus 3. So I'm going to plus 3 to both sides of the inequality. And then you get 2x minus 1 is smaller than 7. Now it's by itself. So now I can make my cases. I say 2x minus 1 is smaller than 7, or now I got to make my negative case. And I need a flip. Remember, when you make that negative case, you flip that inequality. Or 2x minus 1 is bigger than negative 7. And then I'm going to use my algebra. Plus 1 to both sides, and you get 2x is less than 8, x is less than 4. Plus 1 to both sides. 2x is bigger than what? Negative 6. X is bigger than negative 3. And you can kind of think logically about this too. If x is smaller than 4, it's going to the left, right? If x is bigger than negative 3, it's going to the right. They're really going to collide together, is what's going to end up happening. But if you draw a graph, 1, 2, and 3, 1, 2, 3, 4, I have x is bigger than negative 3. That means it goes this way. X is less than 4 goes this way. They're going to smash together. It's an AND graph. And today what your expectation is, what you're going to be given is more like the first set of notes. You're going to be given an inequality absolute value, and then they have graphs. So you're going to have to find the match. What I would do, because my brain, it's hard for me to find the match, I need to draw it first. Okay, this is what I know it should look like. And then you can graph it. Identify the match there. Divide both sides by 3. Why am I dividing by 3? Because the absolute value needs to be by itself. And then you get absolute value of 4x plus 3 is bigger than 5. Now make my cases. 4x plus 3 is bigger than 5. Or, now I need to flip because I'm making it negative. You got to M, D, and F. Or 4x plus 3 is smaller than negative 5. Then I solve. Minus 3. 4x is bigger than 2. It's not 2. It's x is bigger than 1/2. 2 over 4, 1/2. Or 4x is smaller than negative 8. X is smaller than negative 2. This is an or, isn't it? Because if you think about it, if you're bigger than a half, you're going this way. If you're smaller than -2, you're going that way. That's an or graph still. And you want to know, there is a little trick to learn. I always stunk at memorizing. So I actually like to draw my graph and see if they're going to collide or stay separate. But there is a trick. If you start out with less than, it turns into an and graph. If you start out with greater than, it stays or. And maybe you'll write that on your note because it will be beneficial when you identify your graphs. Now let's just summarize that. Notice I started out with a greater than. If I started out with a greater than, it stayed or. I started out less, it turned to an and. So I will summarize that little trick for you. What do I want to say? If it starts out greater than, I don't need the line under it. If it starts out greater than, it stays or. If it starts out less than, it turns to an and. Okay? Maybe some of you are great with just memorizing that. Me, not so much. I like to draw my graphs. But some of you are like, well, just tell me the trick. Just let me know what it is, and I'll apply it from there. So that's if it comes in handy, or when you get done, you can just quick reference your notes. Was it bigger than at first? If it was bigger than at first, then it's going to be an or, so you should be looking for the graph that goes in separate directions. If it was less than at first, it turns to an and. You should be looking for the one that's connected. Okay? And that's it.
Yay!